one of the aspects that we started talking about today was just the number of days that you track students will be missing. We counted 12, but so I'd say it's safe to presume that you'll be gone for 9 to 10 of those for sure, just because of weather in general. So anyway, please read that problem to me about density. Oh, it doesn't say what. Okay, so if the density
of an unknown gas is 3 kilograms, 3.20 grams per liter at negative 18 degrees Celsius.
oh, that's not very good. I meant 18 degrees Celsius.
And 2.17 ATM.
Okay.
What is the molar mass of this gas?
I'm just going to capitalize that because also the variable is molar mass of this gas. Do you know what this reminds me of? No. Well, you might think so, but there was a gal who worked for Mars candy bars, packaging the M&Ms. She kept throwing the W's away instead of the M&Ms. She didn't keep the M&Ms. She kept throwing the W's away. Oh, I guess it wasn't that funny. Oh, okay. All right. So if we tuned into the Science Channel, I epically failed yesterday because my algebraic skills weren't very good. Okay. So if you're going to do this, you'd say that this side is going to get divided by RT. So N equals RT over PV. Okay. Just wanted to clear that up in case you had watched yesterday. All right. So, what is the formula for density of gases?
MP over RT.
132.
Okay, so what do we know in this problem then?
D. 13.23. T. 255.
Now, you're doing the math in your head, which is great. You are subtracting 18 from 273, or if you wanted to add a negative 18 to 273, you get the same thing, which is 255 degrees Kelvin.
Pressure.
It's got to be in atmospheres, 2.17 atmospheres, okay? Okay, because that's our constant. So it's asking for N, which is measured in, again, your molar mass. All right. So we want to get M all by itself. Okay. So you can do two things at the same time. Let's cross multiply by DRT. Okay, so we just cross multiplied. We did this times these two. Okay. Now, this is under the presumption you just want to get M by itself. Or you can just plug these into the equation too. I epically failed you again. Because that N is moles, this is molar mass. Maybe that's what's throwing you off. So what makes the most sense? Doing this first to get M by itself or just utilizing that formula? You're doing the same thing.
That one's faster.
Okay, the one in the black?
That's the way I did it.
Okay, so we can do that. You would just do what the formula tells you to do. Okay, so just put these in their respected spots. Okay, equals what goes on top.
0.17x.
X, Y, M, any one of those. That's fine.
Over 0.0821.
Okay? So then, just like we had illustrated earlier, you're going to take these two times each other, times 3.2, and we're going to rewrite this equation as 2.17 m.
Equals 0.26
Okay?
times 860. I hadn't done that yet. No, it equals 21216.
Okay, there's got to be, is it right here?
No.
With that small of a
right,
number,
yeah.
okay?
66.23 G's.
66.23. Okay? So, get m by itself. Okay? Each side by 2.17.
34.55.
And since it's a molar mass, it's measured in grams are going to be part of it because it's a mass. So what's the mole part of it then?
Divided by, what is it, grams of mole?
Okay?
Oh,
Grams per mole. Okay? So that's what you'd be looking at for your molar mass on whatever number on the back page dealing with the density. Okay? Number 6. Number 7. It's either number 6 or number 7 in case you're tuning in.
It's 6.
Okay?
So molar mass is in grams per mole.
Grams per mole. Yes, that's correct. All right.
What's R again?
It's a constant
What's the constant? Oh, point, yeah.
right there.
So, M and N are the same thing in
No.
formulas?
They are not. Okay. M is grams per mole. N is just moles. Yes.
Well, M is moles?
No. N is moles.
M is grams.
Capital M is grams per mole. Yes. That's why you say molar mass. Just like anytime you would look at the periodic table and say you've got this substance, so its molar mass is 23 plus 35, so somewhere around that. That's why I refer to that as a molar mass. It's whatever it comes in off of the periodic table. All right. If there's nothing else, the rest of the time then is yours. We'll just have a short evaluation tomorrow. Then the gas stoichiometry. It's again, I don't mean to keep repeating what we said over and over. We'll be entering what I think is the toughest part. Some people can say, well, it really wasn't that hard. It really wasn't that bad. Okay, but the reason that I would say it's so difficult is because you're taking a volume of a gas and correlating how many grams of a substance produced that gas. Or you're taking a solid and reacting with a gas, so how many grams of that substance would produce how many liters, milliliters, cubic centimeters of that gas. So that involves the chemical reaction. So that's why it makes it more difficult. Anyways, that's all I've got, so we will catch up to you next time.